This is section 2.6, and we're going to deal with limits involving infinity. And there's two rules we want to remember: that the limit as x approaches infinity of 1 over x is equal to 0, or as you approach negative infinity. So the strategy is to, if you are determining the limit of a rational function as x approaches plus or minus infinity, you're going to divide the numerator and the denominator by the highest power of x in the denominator. So in other words, in this example, limit as x approaches infinity of 5x squared plus 8x minus 3 over 3x squared plus 2. Well, the highest power of x in the denominator is x squared. Okay? And so we're going to divide every piece by x squared. Every piece got divided by x squared. This one simplifies to 5. This one is 8 over x. This one is minus 3 over x squared. Those go away, so you have a 3. That's 2 over x squared. So now, the limit, the rule says 1 over x. It doesn't matter about the power of x on the bottom. If you have a number and x to a power, that's still going to go to 0. So here we had 8 over x. That becomes a 0. That becomes a 0 as you approach infinity. This is a 3, and this is 0. So it's 5/3. That would be the limit as you approach infinity. If you put it in your calculator like this, you would see a graph, and as you go toward infinity on the x-axis, your graph is approaching 1 2/3 or 5/3. So you could check that, but that's the rule. Now, it should look familiar from your algebra. We learned about horizontal asymptotes, and the rule was if the degree of the top was the same as the bottom, then you went to the leading coefficients, and that was your horizontal asymptote. Well, that is your limit as you approach infinity. So if you had to show the algebraic strategy, that would be it, but you actually can see that it would be 5/3. The limit as x approaches negative infinity of 11x plus 2 over 2x cubed minus 1. So again, the highest power is x cubed. If we divide it everywhere, that simplifies to 11 over x squared. That's 2 over x cubed. That's just a 2, and that's minus 1 over x cubed. So this goes to 0, 0, and 0. And this is 0, so now you have 2 on the bottom. But that ultimately is 0 over 2, which is 0. Now think about the rules for horizontal asymptotes. If the degree on the top was less than the bottom, then y equals 0 was your horizontal asymptote. So this all ties back to the stuff that we started learning in algebra about horizontal asymptotes. There is another rule. The limit as theta approaches plus or minus infinity of sine theta over theta is equal to 0. So that is a rule that we might need to know. Asymptotes, we know about the vertical asymptote. This is back to algebra. That is the boundary, and it has to do with the, often on a rational function, it's the denominator. Where is that restriction? But it's as x approaches a from the right or from the left, and the graph goes that way or perhaps down this way because it cannot exist at the vertical asymptote. And then I had already mentioned if the degree of the numerator less than degree of denominator, then it's y equals 0. If the numerator is higher degree than the bottom, then you don't have one. And if they're the same, you have the leading coefficient over the leading coefficient. So those are remembering from algebra. All right, let's go look at our problem set. All right, number 1, using the graph, evaluate the limits that you are asked to do. So the limit as x approaches 6 of f of x. So as we approach 6 right here from either way, whether we're coming from the left or coming from the right, we are at -4, so that would be that answer. The limit as you approach -1 from the right. So if I'm going toward -1 from the right, where is my function going? It's going to -3. So there's that. C, limit as x approaches -1 from the left. So if I'm coming into -1 from the left, where is my function going? It's up here and it ends at 6. The limit as you approach -1 in general. Remember, coming from the left, we went here. From the right, we went here. If those are not the same, the limit does not exist. You can have right side limits and left side limits, but if those aren't the same, it doesn't exist in general. The limit as x approaches 4 from the right. So as we're coming in to 4 from the right, where do we end up? -4. 4 from the left, as we're coming into -4 from the left, it's going up towards infinity. The limit as x approaches 4 in general, so those two are different. We'll just go back to our answers right there. From the left, it was infinity. From the right, it was -4. So in general, the limit does not exist. H, the limit as x approaches infinity. So as we go towards infinity, we're going here. What is my function approaching? It's approaching -2. And then for negative infinity, as I go toward negative infinity, my graph is approaching +2. Sorry. So that's about those graphs. Let's look at number 2. Find the limit of f of x equals 7 over x minus 12 as you approach infinity and negative infinity. Okay, so remember that the limit there's our rule. As you approach infinity of 1 over x, it's equal to 0. And so we've got that minus 12 there. So it's going to be, so this will go to 0. And this will go to 0. So it's minus 12 for both positive and negative infinity. Number 3, the limit as x approaches infinity of -6 plus 8 over x, and on the bottom we have 6 minus 6 over x squared. And so we have, like, write it as two different pieces, if you will. So the limit as you approach infinity of 6 or -6 or 6, you just get those numbers. This piece, this limit piece, goes to 0. So we have 8 times 0. This piece goes to 0, limit as you approach infinity. And so you've got plus 0 and minus 0. That ends up being -6 over 6, which is -1. And it would be the same for negative infinity. Number 4. Whoops, went too far. There we go. Find the limit of this trig function as t approaches negative infinity. All right. So we do need to divide the numerator and the denominator by the argument that is in the bottom, the argument for sine or cosine. So both of them, the argument is 9t, but in the bottom, in the denominator, that's what we're doing. So we're going to divide 7 by 9t, this one by 9t, that, and that. This one is like the 1 over x, that goes to 0. This one is just 5/9 because the t's cancel out. This one is our rule for sine theta over theta as you go to infinity, and that's a 0. On bottom, you have 6 over 9 because the t's cancel, and here is cosine, same rule as we had for sine, and that's 0. So now you have negative 5/9 divided by 6/9. To divide them, we'll flip this and multiply. Those cancel, and you're left with negative 5/6. That should be the limit as t approaches infinity, negative infinity. Okay, number 5. Find the limit of the rational function 11x to the 4th over 4x to the 4th plus 20x cubed plus 8x squared as you go to infinity. So we're going to divide by the highest power of x down here. That would be x to the 4th. So everywhere we're going to divide by x to the 4th and simplify. That becomes 11. That becomes 4. This becomes 20 over x. And this becomes 8 over x squared. Now the limit as that goes to infinity is 11 over 4 plus 0 plus 0. So that is 11/4. Number 6, same idea. What's the largest power of x in the bottom? X to the 8th. We'll divide every piece by x to the 8th, and we simplify, and we get 8 over x plus 4 over x squared plus 8 over x to the 8th over just 5. So this one goes to 0, to 0, to 0. 0 over 5 is 0. And if you think back to the horizontal asymptotes, the degree of the top is less than the degree of the bottom, so y equals 0 would be your horizontal asymptote. All right, number 7, we have a little bit some strategy stuff going on here. Let's see what's happening. So this is the limit as x approaches negative infinity of, and then we've got some radicals. So we got 5th root of x minus the 8th root of x over 2 5th root of x plus 8th root of x. You want to rewrite those as fractional expressions. So this is x to the 1/5. Remember there's an understood 1 in here, and 1 over 5. Minus x to the 1/8 over 2x to the 1/5 plus x to the 1/8. The biggest power here is the 1/5 because 1/5 is larger than 1/8. Divide by that everywhere. So you've got x to the 1/5 over that. Divide there, divide there, divide there. Then we start cleaning it up. That just becomes 1. That becomes x to the 1/8 minus 1/5. You subtract your exponents. That becomes just a 2 on the bottom. And this is x to the 1/8 minus 1/5. And so when you have 1/8 minus 1/5, you have to get a common denominator. So that's 5/40. Here, I did that here. 5/40 minus 8/40. That's 3/40. So that's how I came up with that. Okay. So you do get negative 3/40, but that means you're still on top. You're x to the negative 3/40. When I put it back in the form, then that's 1 over x to the 3/40. This is 2 plus 1 over x to the 3/40. Those both go to 0 when you take the limit to infinity or negative infinity. So we have 1/2 as our answer. Okay, so you had some radicals, you had some fractional exponent things going on, but that should be okay. All right, number 8, we have another strategy we want to use. So on the top, we have square root of 4x to the 4th plus 1. On the bottom, we have 5x squared plus 2. Hopefully you can see that the square root of x to the 4th is x squared. So if I say I'm going to divide by square root of x to the 4th, that's going to help me with this one as well. So I divide everything by the square root of x to the 4th, this whole radical and this whole radical. When I do, this just becomes 4 plus 1 over x to the 4th. Okay. because it's under the radical. And this becomes just x squared, and you have 5x squared plus 2 over x squared. So now we can write this like this, the 5x squared plus 2 over x squared. That's going to, if we break those into two pieces, that becomes 5. And then we have 2 over x squared. And then on top we have square root of 4 plus 1 over x to the 4th. Well, the limit as you go to infinity, this piece goes to 0. This piece goes to 0. And so you have square root of 4 over 5. That's 2 over 5. And that should be our answer. Number 9, find the limit as x approaches 2 of 7 over x minus 2. We're going to use our grapher. If we put that in our grapher, we get a rational function that looks like this. And we're approaching 2 from the right. As we're coming towards 2, where's our function going? To infinity. As you approach 2 from the right, you go to infinity. Same thing for number 10. The limit as you approach negative 15 pi over 2 from the left of 4 tan x. So if you put 4 tan x in, and this is what I did here, and it looks, they go like that, and as you approach, that would be 7.5 pi. Well, you can tell each thing as you go toward any of them, where are they going? They're going to infinity. So even if you come in from the left, they're going to infinity. So you should be able to see that on your calculator. And that should get us through 2.6.